Download. Okay, it's failing actually. Let me check. Let me reshare it. Okay. My account is able to download. So let me reshare it. Share. Okay. Then one thing I will do, I will upload this one right now in MS Team files. Okay. So I will create a new folder, dev 5.
Go to the lecture content and PPT.
Okay. Your sound is not audible actually.
Go to lecture content and PPT. Lecture content code underscore PPT.
Your sound is not actually clear. Let me use my headphone. Yes, Durgesh sir. Hello. 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 Hello.
है तो
हो क्या रहा है प्रॉब्लम?
मेरा तो हो गया डाउनलोड।
मेरा वहां पे फेल हो रहा था। आपका हो रहा है? आप okay. Durgesh sir will upload a zip file. If someone is facing with the download problem, then it will be uploaded in Teams file section by Durgesh sir. Okay. And right now I will start the session. You can download from there. It will be soon uploaded in the files tab. So I will start the session. Am I audible and screen is visible to all? Please write in the comment box so that I will start that session. Anyone? My screen is visible. Am I audible? Please write in the chat box, please. Yes. Okay. So today's session, we will start with plotting using Python. And for today's session, I will cover two libraries, matplotlib and cbond. Matplotlib is the base library used for plotting for static plots. And cbond is the statistical plotting library that is used for statistical plotting like box plot, bar plot, all those stats where we have to count some statistics and then we would like to plot. Those cases we use a cbond. Though cbond uses the same in the background, the matplotlib as a base, still it is very easy to use. And in this lecture, I will cover the line plot, bar plot, uh, then pie chart, box plot, Boxen plot, then violin plot, bee swarm plot, distribution or histogram plot, then scatter plot, joint plot, and pair plot. Okay. And the learning resources, if you would like to learn this, there is also a course link. Okay, dataset zip file. Okay, it will be uploaded soon. Okay, in this files tab in the Teams by Durgesh sir. I guess he's making the zip file, preparing it, and it will be soon uploaded. Till now, you can go see the lecture only. Okay, and to plot this or generate these plots, we need a few libraries, predefined libraries. I will import the NumPy library as NP, then pandas as PD. Both are required for data manipulation. And for plotting, we need to load the library matplotlib. I hope you have installed those libraries, matplotlib and cbond, from in your environment, that is our data science environment, using the Conda or Anaconda. Okay. If it is not, initially you have to install those libraries. You have to activate the environment, and then you have to use the Conda install matplotlib or Conda install cbond. These two libraries will be used. So first, for importing libraries, I'm importing the NumPy libraries because sometimes we need that, and the pandas for data manipulation or data wrangling. Then we have to import the matplotlib.pyplot module from that as PLT. PLT is the alias name or nickname, so that we will call every time the pyplot as .plt. Okay, thing went wrong. So there is a network issue, so it's now resolved. I hope I'm audible right now. My screen, I'm also visible. Please write in the chat so that again I will start the session. Is it visible screen and I'm audible? Yes. 1 4 10:41. Okay. Okay. So these two libraries we will import, the NumPy and pandas as NP and PD, and we also need the library matplotlib. From that we will import the pyplot module as PLT. It is the nickname. Then we will import the cbond as SNS. That is the short or nickname for cbond. This will be used for our plotting purpose actually. And for session 7, I will start with a line plot. So one by one, I will go through the plots. I will show from scratch how matplotlib actually plots in or take the data and plots the things over the axis. Okay. And so the first concept that we need to know is the line plot. That is the basic plot that we usually use to plot some points and connect the lines. So every time whenever I will show some plot, talk about some plot, I will show what that means actually. And this is a line plot or line chart where say our tip data in x-axis we are plotting the index values, and in y-axis the different features. Like in first, this orange one is for tips and this blue one is for total bill. So in a sequence from 0 to 244 observation, we have plotted the index values in x-axis, and in y-axis we have plotted the points for total bill and tip. It could be anything. You can plot in x-axis, say time series data like date, and also plot how the different values are fluctuating over the different points. So line chart is nothing but a visual representation of data in the form of points that are connected in a straight line. Okay, in a straight line. So let's go for the plotting part. So whenever we have to create a plot in matplotlib, first we have to instantiate and create a axis object and figure object. Okay, so what that mean actually? So we have imported the matplotlib as the pyplot module as plt. And now what we'll do, we will do the plt dot, and there is a function or method called subplots. And inside that you have to give what will be the figure size. So fixed size equal to in a tuple 16,7. That 16 means it is in inches. So it is the width and it is the height. The first one is width and second one is height. Then with comma, we can also define how many subplots. Sometimes we have to plot multiple plots, say 4 by 4, 16 plots in a one plot in a grid manner. So how many plots you want to be in row, how many rows it should have, and how many columns it should have. Say, just for example, we need 4 rows and 4 columns. And if I run this, okay, first also you have to run this, okay? So load the libraries. And once you run this, it will return you two things. Okay, uploaded content in the team. Okay. So it will return two things. One is called figure object that contains 16 axes, and another array of different axes. So total 4 rows and 4 columns. So total 16 objects it should return. So here you can see in a list of list, it shows that first row contains 4 columns or 4 object of plot. Second row also contain 4. Third row also contain 4, and fourth row also contain 4. Okay. So how it look like? It will look like this, like 4 by 4 grid. You can plot a line plot here, you can plot something here, you can plot something here. And how to access those plots, we will see how to access the locations where we have to impose those plots. Okay, so it returning two things. One is figure object, another is axis object. And this axis object we need to impose everything that we want to plot. Okay, so next let's, what it returning, it is returning figure object and axis object. Okay, so containing the axis things. So what we'll do while instantiating this subplots, blt.subplots and figure size and number rows and number of columns, we can directly give save it in figure comma axis. So first what is written, it will save in figure, and second it will be saved in axis. This figure object should be saved in figure, and this axis, all this axis object should be saved in axis. And once you run that, it has been actually saved in those two things. One is figure and axis. We mostly need the axis object to impose our plots. So let's create one blank plot or a blank canvas. We can say that, and it doesn't contain 4 by 4, but a single plot. So we have to just instantiate it with plt.subplots, and figure size would be 12-inch width and 6-inch height. That is inches. Okay, it is actually developed in 2007 and mainly for office works, and so that if you read the history, that's why it has been till that point has been still in inches actually, not mm or centimeter. And we are saving this. Now we have instantiated a blank plot. We are saving the figure object and axis object. And now it is a single plot because we haven't given any instruction that how many rows and how many columns we need. So it automatically instantiated a single plot, blank plot. And this blank plot has several features, like this is a x-axis object, this is a y object, y-axis, and this is the x-axis. And these are the different values. By default, matplotlib, what it does, it will limit the range from 0 to 1 for both the axes. And these lines are called splines. Okay, S-P-L-I-N-E-S, splines. We will later see how to remove these splines or how to modify. And this things is known tick, this small that is a horizontal bar that denoting our values. That is called a tick object. And this is a tick value or tick label. Okay. So these are the standard term that will always will face while plotting a particular, while generating a particular plot. And this is the canvas. So what we'll do, we will take this axis object and impose everything, a line, a bar, any plot you want to plot, you have to impose on this axis objects. So let's try, and first, before we proceed to the line plot creation, first see how is the DPI. So figure object also contains different features. Like first, let's see what is the DPI of this figure. So figure.dpi, if you enter, it will show that it is 72 DPI image. But for publication, sometimes we need 400 DPI, 600 DPI, maybe 1000 DPI. So it is also possible to modify the DPI. We will later see how to improve the DPI so that it will be directly publication ready. So let's first create a line plot. I'm not audible. Am I audible? Someone has posted. I'm not audible. Okay. Yes. Okay. I'm audible. So please check your internet if you are not able to see my screen, or join again the session if the problem still there. Okay. So first let's plot a line plot. How we will do that? This will not be required for plotting a publication ready plot, but it is just for showing how Matplotlib build anything from scratch. Okay. So first I will comment it out, and first we will import from matplotlib.lines. We will import the module the lines module, line 2D module. Okay, from matplotlib.lines we will import the line 2D module. Okay, and this line 2D module we will use to plot something. So first we have to generate some values in the x-axis. So what we'll do, I will use the numpy linspace function, and I will give instruction that start from 1 and go up to 20. So a range from 1 to 20, and divide this range into 10 equal blocks and return me the object. So if I print it, so it is like this. Okay. 1, 3, 5, 7, like this. It is automatically defined in equal blocks. And let's say I want to also, I need also y values, because it is just giving me x values that I will plot in this x-axis. But also for a line plot or for a dot to be, we need x and y values. So we want to create two line plots or lines. So first I will define a y1 object that is called our y1 values. So let's say corresponding to this one, that is 2, this for 3.11, this is 3, for this one it is 9, and again another list for y2, that is for 2 lines. Okay, that we would like to impose on the axis. Someone is supposed to, how you commented all lines in once. Oh, that is a shortcut. If you place cursor and press control question mark, okay, then it will be commented out. If you again press, it will uncomment it. Okay. So next I have to define the lines. So we have the x values, we have the y values, y1 and y2, and now we will define the line 1. So we have already imported the object using which so we have the line object already. We have imported the line module. So what we'll do, we have the x axis values, we have y1 and y2, and in line 2D we have to give the x and y1, and we will give a label that is a line 1, because when you plot multiple lines, which one is line 1, which one is line 2, which one is line 50, say, you won't remember. So you have to give a label so that you will prepare a legend. What is legend? I will come to that. So in line 2D, we are giving the x values, we are giving the y1, and label is line 1. Similarly, for line 2, again, here in line 2, we are giving the y2 values, and we are also giving the instruction that label it as a line 2. And we will run this whole cell. It will automatically save the line 1 and line 2. Now what we have to do, we have to impose those lines over the axis object, because we want to add those lines in this axis objects. Okay, the axis objects that we have. So we have already generated the axis object here, figure x is equal to plt.subplots, and figure size is this. This has also a axis object. So we have generated the line 1 and line 2. Now we will impose that on the axis. How we will impose that? Axis dot add line. So axis object has a dot line method in which we will give this first line 1. So given the line 1. In axis again line 2, the line 2. And we have to also use a auto scale so that it will automatically scale out. This is not important, but for plotting this, it is important. So you don't have to remember that. And now we were printing the figure object. Okay, what will happen if I enter? It automatically imposes. I'm using a black version. Let's change the color theme so that you will get a light material theme lighter. Okay. Okay. But it is still not good. Let me change color theme. Visual Studio Light default. This one is good. Okay. Now you can see that our plot is here. Okay. Is this theme good, or should I go back to the black one? Anyone comment? Comment please. Because if it is not visually attractive to you, then showing those plots will not. Okay, black one. This is good. Okay. Okay. So we'll stick with this white one because it will show the axis objects properly. Otherwise, in black one, it will show in dimmed manner actually, not clearly actually. Okay. So we have plotted these two lines, but let's say I want we have imposed this two lines, line one and line two, on the axis object, and now axis object contains those lines. Whether this contains the lines or not, we need to check that. So how we will check? Axis dot lines. If I give this and enter, it will show that axis artist list of two lines. It contains two lines. Okay. So when it contains two lines, we can access those lines using a list indexing method. So how we will access those lines? Let's say I want to change the color for the first line. Okay. Now we don't have the identifier which one is line one or line two, but later we will see. So let's assume that the first we want to access the line one or line zero because it is a Python, it is in zero index based programming language. So start with zero. So axis dot lines, again, this contains two. From that, we are indexing the zero, taking the zero line. And with dot set color, we are setting that to red. And again, we are printing the figure. So let's see what happens. Now we can see that the line one or line zero has been added a color or added a color with red color. Okay. Similarly, what we can do, we can also change the line one, not line zero, the second line. Okay. So axis dot line one, axis dot lines. Inside that, we are taking the line one. Then we are setting an alpha value. Alpha value is a opacity, means how dark or how light you want to make the lines. So I want to provide a 40% opacity or alpha value. Okay. So next, what we can also do, let's say set the line one to dash. Okay. So we are accessing in the axis object the lines, and from that taking the line one, set line style. Different types of line style available. You can search in the internet. You will get the matplotlib documentation where the lines are given, like the dashed line, what would be the dash space. If you need another type of line style, that is also there. So here I'm giving a dash line. Okay. And figure. So now you can see the line one is in dashed, and it is now not that dark because we have set the alpha value or opacity to 40%. Okay. Next thing, let's here where the values are changing, like here it is a kink, there is a value change. Here is a kink for red line, here is a kink in red line, here is a kink in red line. But sometimes they are more frequent. That time you're not able to observe that. Let's say we want to add a circle wherever the values are present. Here a value, here is a value, here is a value, here is a value, like this. So what we can do, we can access the lines, say for the zero line, and set marker to zero. Zero means a circle. Okay. So this marker here will put everywhere there is a value there, that would be represented with a circle. So for line one, also a circle. Then what we'll do, we'll set the marker size. What would be the circle size in pixels? Okay. So set marker size again for the zeroth line, and set marker size to 10 for the first line. So 0 and first line. And if I print the figure again, now you can see that it has added markers. Okay. So circle. And if you want to change the markers, there is also, I hope it works, like triangle. If you would like to change to triangle, any shapes, diamond shape is also there. Star. Let's say I would like to make it star. Star. So you can also change the markers if you would like to change that. Okay. So next thing is how, let's say I would like to change the axis limit. So it is from 0 to up to 20 around. I would like to make it up to 25. So axis object also contains set limit function, set x limit or set y limit. So here I'm setting the axis from axis object. I'm asking the matplotlib to set the x limit from 0 to 25. And if you print the figure, it will show that now it has been extended to up to 25. Okay, so that way, actually in background, matplotlib does it. And now we don't have an identifier which one is line one and line two. So what we'll do, we will call the legend. Legend is not just an identifier what is what in the plot. Okay, so axis dot legend method, and again if I there's the figure, as we have initially given a label. If you see here, the label is this one for line one, this one for line two, while defining the lines. So now it has automatically imposed once you have called this legend method, now a legend is present in the upper right corner. So this is the line 1 and this is the line 2. Okay. So this way actually matplotlib does everything in the background. So now we will, it is just for showing. That way we'll never gonna plot because it is very difficult and the steps are required very actually extensive, like say 50 lines. We don't have time. Later I will show using plot 9 that how it could be made in 5 lines. Any complex plot in few lines with single tweak. Okay. So now we will plot a line plot that I have already just showed in this chart. Actually, this one we will trying to plot. And what we'll do here, we will plot this index values in the x-axis and the total bill and tip like this. And we also add some markers with white inside fill color, and also try to change the x-axis tick labels and y-axis tick labels. We also add a dollar sign because sometimes we have to actually change the or we have to represent something with dollar or say millimeter, something like some unit. Okay, so that could also be done. So let me go to the. So we have already seen the TIFFs data set. I'm directly loading it. I'm not showing how to load it. You already know because in last week's session we have already discussed extensively the pandas. So I'm loading the TIFFs data set. Okay, so here we have this total bill and tip. That would be our Y1 and Y2. Okay, that we want to add as a line. So first, while defining the plots, we have already seen how to put micrometer in the axis level. That could be done. Okay, I will show one by one. And anything that in matplotlib, anything is customizable. Even if you see the black hole image that has been prepared using matplotlib. Okay, matplotlib, pandas, scipy, this kind of libraries. So anything is possible. Just you have to see, you have to look for the exact code or exact solution. It is available in the internet. Whatever I am giving you here, it is more than enough for any research work. Okay, so just let me show first, then I will take all the queries like how to change the axis level or set axis level, or everything is covered. Okay, it is just now showing basics. One by one I will show. Okay, so first let's create a line plot that I already shown you using the PPT. So first we have to define always a figure and axis object where we would like to plot that. We every time you will plot, you have to define it as a fresh. Okay, otherwise it will override the previous one. So now we have to define the figure and axis, and same way plt.subplots figure size equal to 12 and 12-inch width, 5-inch height, and we are saving the figure or return object that return figures and axis. So we are saving the figure object in figure and axis objects in axis. Now we have to plot the lines. So that way we will not going to do it. We will do it this way. So axis also contains a dot plot method. That means this dot plot method directly plots a line plot by default. Okay. So axis dot plot. Anyone in terms of symbol that I will show how to add those symbols, everything. Okay. Even it supports latex. Even if you want to put a equation, that can be possible. In axis or in any place, marking everything. I will show one by one. Okay. So first we are calling this axis object. Over that we want to plot a line plot. So dot plot, and whatever the things you want to plot, I would like to plot the total bill. And the data is tips. Here in tips we have saved the data. So data equal to tips, and label. First we are labeling that this is for this line is for total bill. Okay. So here we are directly providing the y. What about the x? If you not provide a x, it automatically takes the default index values. This, when you read a data frame, it automatically defines a index values, integer values in a increasing sequence. So it, whenever you are not providing any x values, it will directly take the x value as the index value. Okay, so here we are providing the y1 as total bill. So data from tips label is equal to total bill, and axis dot plot. Then another line we want to draw for tips. So tip data equal to tips and label equal to tips. Now we are also asking that please provide us the legend, because we have given the identifier, the label. So matplotlib return a legend. And to set a x-axis label and y-axis label, I will show. Let me comment it out right now and run this. So what it happened that it directly plot the values. In x-axis, it provided the index values from 0 to 244 observations are there. So the index values in a sequence. And in y-axis, we have the values in dollar. And this identifier, the tip is for this orange one. Orange line represents the tip, how the tips is fluctuating over different values in the data set. Like the first one, for first 0, it is tip total bill is 16 and tip is 1.01. Then 1, then 2, then 3 and 4 up to 244, whatever the total observation we have. And this up to 2, this index values are in x-axis and the values corresponding to the tips and total bills are in this axis, y-axis. In same axis, we have imposed those actually lines or points. Okay. So next, say we don't have a what is this x-axis represent and what is this y-axis represent. We don't have that information here. Okay, so how we'll add that? We have to give a label here. So what would be the label? To add the label, we have to use this axis method. So axis dot set x label, and inside that you have to give what would be the x label. So x label, say I want to give the index values of tips. Size would be 14. And similarly for set y label, for axis object, you have to use the set y label. For y axis label, here it will give the label, and it is total bill slash कर देते हैं slash tips. Okay, tip amount, because we are providing both. So just we want like that, and the size is 14. Now if I run this line, it will show that now it has added the axis labels like index values of tips and total bill slash the tip amount. Okay. And here is the label for both the which one is for tip and which one is for total bill. So how I'm getting all this, whether this plot object exists, this plot method exists in axis or not. You can also search in the internet, in Google, you will get the documentation of matplotlib, or you can also use a help function on what this plot method contains. So help axis.plot. If I enter, it will show all the things that a axis object contains, the plot, x values and y values. A plot xy using default line style and color. Okay, different things that you want to know, and you can also open the additional thing. And it is so much documentation that it will take forever. So whatever the thing you need, you have to go through that, and you have to use, and you have to trial and error and see whether it works or not. Okay, so I am again commenting it so that you don't cover too much lines. Now coming to the customization part, how I will customize these plots. Say I would like to add markers, again 0, these circles. So first we access the line 0. So from axis.lines, I'm accessing the line 0, setting the marker to O, that means circle. And similarly for one number line, the line number 1, for line number 0, this one, line number 1, this one, I'm setting the marker. Say for example, I don't want, sometimes it is very clumsy if you say all the points are very near. Say I want the marker to be every 5th interval. Okay, every 5th number marker should be present, and the in between markers should be not present actually, or should not be imposed in the plot. So I want that marker should be given at every fifth number point. Okay, at an interval of 5. So that could be also possible. So first I'm accessing the line 0 and using the set marker every. So I'm giving the 5. The interval size is 5. Similarly for line 1, the interval size is 5. Next thing, that what would be the fill color? Let's first run this and see what happens. Okay. If I run that, you can see that is the points are at every 5th value. Okay. For total bill and tips, both cases. So next thing, what we'll do, set, let's say I want to add, instead of this dark type of markers, I want it to be filled with white color. So same, accessing the line 0 and setting the set marker face color. There is a method available under the axis, and where I'm setting it to white for both, for 0 number line and for 1 number line. And again, I'm adding. So now you can see it is now the face colors or values are now been let it make it big actually, so that you will able to observe it properly. So make it 16, make it 7. You have to rerun the line, and now if we add that, now you can see that the markers are filled with white color. At every fifth marker has been highlighted in the plot, and these are the axis labels. This is the legend that is representing what means what in the plot, which line represent what. That is actually legend. Next, let's say someone asks you to add some, say, dollar value. So you are representing this tip, whether it's in rupees or dollar. Say, for assumption, it is a dollar value, and I would like to add a dollar symbol before every value. Okay. So how we will do that? So matplotlib also obtain different types of formatter object. So formatting, it is called formatting the values or labels. Here are the tick labels. Okay. So how we will do that? So from matplotlib has also a ticker class. Okay, what is class? You will not understand right now, but just remember that it is a blueprint for the matplotlib for printing different values or changing the format of different labels. So from my matplotlib.ticker, we are importing the str string-based method, str method formatter. Okay. So what this formatter it will do, it will change the format of the how it the labels are look like, or tick labels are look like. So after importing that, what we are doing, we are taking the such a formatter function, and inside the quotation we are giving that with dollar sign, because we want to put a dollar, and again inside that value we are giving x and asking it to giving a float value or decimal value up to 0. So it will just add a 0. Okay. And we are saving this formatter into mft, a variable name. So what will actually do, it will change the all the values. Here x means not x values, it means just values. So take every value and put a dollar sign before that. And what we'll do, we are saving that in mft, and this mft object we will use to set the format of the y-axis tick levels. So how we will do that? So we are again taking the axis object. From that we are accessing the y-axis, and inside that we are accessing the set measure formatter. So okay, again it's gone. There is an internet issue. I think now I'm audible. I will share the screen again. So this is the problem with technology. Am I audible right now? I'll share the screen again. If you would like to take a 1 minute break. Okay, someone has posted that. Okay, string formatter print up to 1 decibel. I hope it is clear. So I will resume it in 1 minute. Till then, If you have any question, you can post. We will try to answer that. My screen is visible and am I audible? Please post. That is also in comment box. Okay. So we'll proceed with the lecture in 1 minute. Okay. So let's take 20 to 30 seconds. If you have any question, you can post that. Else I will proceed. Which format is best for outputting? In terms of what? Which format you are saying? In terms of what? Whether you want to change the label, PDF or .png. Usually I prefer PNG because its quality is good. JPG is also good, but when you increase the DPI to 400 or 500, then it doesn't matter. Though the size matters. Okay, so output size will be higher for, I guess, PNG. I hope, but I'm still in. I can't confirm that, but I usually use the PNG format for publication. Yes, if you want to alter something, you have to use the module. Actually, here we are altering the tick axis levels. Okay, so whatever the default level, it is in numeric. So to alter that and to paste that, we need a string formatter, because while adding the dollar, we are adding with a numeric value. So we need to convert it to string. That's why we are using the string formatter here. Otherwise, if you want to add a string with a numeric value, it will throw error. So matplotlib ticker has a string formatter method. Okay, so that's why we are taking the string formatter method and adding the dollar value and printing with .0. That means it will make it I hope a decimal value, actually, like $50.0, like that. Or let me print that. Okay, so I hope I will start now. So to import here. Okay, so from matplotlib ticker, we imported this string method formatter. Then in string method formatter, we added the dollar value before every value in the tick label. And then in axis object, we are accessed the y-axis. And inside that, in y-axis, we are setting the major formatter to this MFT, whatever the variable in which we have saved that. Now, we would like to also, first let's print this, make it comment. And what we'll do, it will, now you can see that a dollar value has been added. Okay, a dollar symbol before the values. And let's say I want to increase this font size of the tick levels because it is not visible. And in plotting or for publication ready plots, it has to be big enough so that everybody can see it clearly. So we can also do that. This axis has a method called tick params. So axis dot tick params. So that means tick parameters. This axis object, you can either use the X, you can use the Y, you can use the both. Okay. So tick parameters, here you can, if you hover, it will show axis, literal X, Y, or both. I would like to change for both axes, X and Y. So that's why I'm providing here axis equal to both. So label size, what would be the size? I'm adding it to 12. You have to play a game like trial or error game, like whether 12 is useful or 14 is useful. There is no standard method for defining that. Whatever you like useful, you have to give that, and if it is acceptable for you, it is okay. So for me, it is 12, and the label color will be red. For both axes, the label color I would like to set it to red. And if I print the figure object again, now you can see that it is now in both the figure level has been set to 12. If you want to change it to 16, it can also possible. It will increase the size and also in red color. Okay. So now the part comes how to save the plot. So you have created the plot, but you want to export it. All types of format is acceptable by matplotlib, like PDF, .png, JPG, other formats are also there, but these are the common formats. And you can also increase the pixel density or the resolution. So here, whatever the plot you last plotted, that is in the environment, actually in this environment. This is the last object we have created. And And it is also saved inside our axis object that is defined here, I guess, axis and figure objects. Okay, that also contain those materials that you have altered in the plot or you have changed. So right now in our instance, in current instance, this figure object has this kind of attributes. Like we have changed it to added a dollar, changed the color of the labels, and also added the X and Y axis labels. Okay, and also added a legend. And this plot we want to export. How we will export that? To export that, we have to take the figure object, and this also has a method called savefig. So this figure object also contains a savefig method, and inside that we have to give the path where you would like to save. Right now I am in this folder, and this folder also contains the images. Okay, so here I would like to save. So images slash the plot or the plot name. The plot name would be linechart.png. I would like a PNG format. And the DPI I am setting %% equal to 300. And if I enter, it will add this plot in this location in the images. Okay.
So I would like to add here.
Okay.
This line is giving error. I know because they have images folder.
Okay.
So this line might be giving error for you because you have not saved or created the image folder here. So you can create the image folder like using the import OS and like os.mkdir images.
Already created.
So for that, for those, it will not overwrite. It will throw an error if it is already exist. For all of you who have not images folder, it will not give an error. So again, we can use the try and except block, try os.makedir, okay, and except either we can ignore or print that dir already exists. Image dir already exists. Okay.
So in my case, it is already there.
Yes.
Image dir already exists. In my case, the dir directory is already exist. In my case, the directory is already exist in the right. You can see here that whatever the folder I have imposed in that images folder is also there directory. That's why when we use this try and accept, it will pass this. It will not create a new folder, but it will accept this. Accept what? That the directory already exists because I have that directory. In your case, it will create a directory if it is not there. And after that, you have to give this path images slash because you are saving in the image folder, then slash linechart.png. If you want to save anywhere else, just remove this image line and it will save in the current directory where you are right now accessing this Jupyter notebook file. Okay. Because I want to save all the figures into a particular folder, otherwise it makes the directory clumsy because my directories look like this. Let me show you because if it create confusion, my directory is here. I'm accessing this directory that contains dataset, images, joins, and I don't want to save in this directory because I'm accessing through this VS Code. I'm accessing this directory only. I'm in this directory. You can put it anywhere in the directory. And majority of the cases while we're doing programming, we will keep it in the desktop. It's okay. So I'm accessing from here. That's why I have an images folder. That's why it might have been giving an error because you don't have. So you have to create a folder here, either using that method or right click and create images. Then it will automatically save on that folder because I'm giving the path here. Okay. So where is that? Okay. The path. So figure.savefig, then path is data images. What will be the image name? Linechart.png. What will be the DPI? It will be 300. And if you press enter, it will save that in that folder. Let's go to that folder and line chart. Here. Copy it because it will. My Windows is in dark color, so it will not properly show. So that what I'll do, I will use Word and paste it and show you that how the resolution look like. So it is our plot, but it has a blank space around it. What you can do, that is another method.
Wait. So let us make sure that they cover at least basic plot. So this is simple, very simple assignment. They have to try it in 5 minutes now. First one, okay. So that they at least get the basic with the minimal level of the code. Right now. Yeah, right now, 5 minutes.
Durgesh sir has given one assignment. So I hope you have learned how to create the plot. And here are two assignment right now you can try using that method. At least for right now, I will give 5 minutes. After that, Durgesh sir will show. Yeah. Just try whether you're able to do that.
So that at least minimal level of thing you take.
Then we will proceed to the advanced things that is there. So try this whether you're able to do that. Okay. Create a plot using create a plot where y equal to x square and the range is -10 to +10, and using matplotlib. Set the x-axis and y-axis level. Similarly, create a subplot using a plot y equal to x square and y equal to x cube, and plot in the same axis object to see how this changes from -1 to -10 to +10 using matplotlib, and set a appropriate legend. Okay. Try that whether you are able to do that or not. पेज बढ़ाना पड़ा। नहीं ठीक है, ज़्यादा पेज इसी में फास्ट So I will try to code along with you so that first part is importing library. If nothing you remember, just remember import matplotlib dot iplot as plt. Okay. Then you have to define x and y. Define x and y. So suppose x is a list, so you can create a range from -10 including 11, so that 11 will not be included, and with a gap of say 1. So, and typecast is to list. So we can see that print x, so it is created. Okay. So then we have to define y. So I am using a list comprehension. It is very simple. Just pay attention. So I will see item into item. So I am making item into item for item in x. So this will be print y. It is this way of I am encoding the like the for loop into a single line. This is called list comprehension. So it will show you the y. Now you have to create ax fig comma ax object, and you have to create plt dot subplot. Subplots, and like even if it is a one plot, it will automatically create one plot if you are not giving anything. Then ax dot plot, and then you have to just give x and y.
this will create even the fig dot show. Even if you don't try this, it will show you like it is a bell like curve, x square curve. So now you can customize this, add the title, and here there are two objects. One is the complete figure object, other is the axis object. So now you have to x dot set x label, x label. Suppose we are telling just x, we are telling x, okay, and similarly set ax dot set y label, y label is y or y x square. Say y label is x square. So on x and other is x square. So this, and then we can finally give plt dot so any, it is not required, but we can give it. Then it is a simple like the, this is the minimal light when you have x and you have a y. One need the necessary condition is that both dimensions should be same, like the x and y dimensions should be matched. Otherwise it will throw an error, the dimension doesn't match. Similarly, for if you want to, yeah, so if you want to like the give a y2 which is a y cube, so you can just use same list comprehension. So you want, this is item is a temporary variable. So suppose I want to change it to v. V is a variable name. So I can even write v into v into v or v in x. So it will be y2, then ax dot plot xy, and then ax dot plot x y2. Y2. Uh, yeah. Label to x square, and here label equal to x cube.
Axis dot legend.
Yeah, that I am showing later. So there is an error, x dot plot label x2 must have same first dimension. Why it is coming for v cross v? Wait, print y2.
y2 you have y2. Okay, वहाँ पे गलत लिखा है. Y
Oh,
underscore 2.
okay, okay. Y underscore 2. Thanks for pointing typing mistake. So it is there. So it is not x square is not like the perfect curve because we have to set the limit like the x cube which is going like this. So if we reduce it to something like -4 to 5, then we can see better plot, little better.
Because both plots are imposed in one, that's why
Yeah.
the unit is.
So x dot label.
We can resolve it with a twin axis.
Yeah.
Okay, okay.
1 second. X dot set legend. X dot legend. Yeah, by default it will take automatically, but we can also give our explicit legend. So x square and x cube. This is the plot. So this is just summary that within 8 to 10 line you can create a basic line plot, scatter plot, like anything. Like instead of plot, you can do the ax dot scatter plot. So
I will show.
yeah, so this is the minimal thing I want to show, that even if you don't know much customization, with the minimal 8 to 10 line you can plot.
E to the power x, y.
Yeah, np.exp. So you just need to make the np.exp.x.
The numpy library and also.
Yeah, you have to import numpy library, and there the exp function is there. So you can define np.expx.
That could be possible. So next, I hope you have learned that simple functions can be plotted using matplotlib, even complex functions. So, and even 3D functions, that is also possible. So we have already created this one. I will comment this one right now.
You can just show here only save how to save this plot.
This one.
This one.
Okay.
In the same image directory.
So if you would like to save this plot in the image directory, we have already created the, we have already the axis and figure object. Yes, here it is. So it is also contains a figure object. We can save that also. So again,
no, there it's in the last line. You just
okay, last line we can add here. Fig dot save fig. Okay, and here we'll plot that function. In the datasets or images folder. So function dot png and the DPI equal to 300, and if you enter, it will plot plus it will save. Now you can see that the function, I hope it is there. Yes,
function.png.
now it is here. Okay, the plot is here. This way you have to save actually. So I will comment this out so that it won't interfere what we are plotting earlier. Okay, so I will run that and from the initial so that it won't overwrite. We have created this line plot. We have added the markers, and we have also added the $sign with the string formatter, and we saved this image in as a line chart in the images folder. Okay, next thing what we'll do, that line chart has one thing that we want to remove, like say this line chart. It has this spines lines, okay, this 4 spines lines, this top one and right one. Sometimes we don't want that, this top one and right one. So how we will remove that from the plot? That
bounding box.
Oh, bounding box. It is called splines actually. So how to know that how many splines it has? So if I type the axis.splines splines, so it will give me a spines. Then it give me a spines object, but we have to iterate through it so that it will show us that how many spines it has. So what we'll do, we will iterate through it. Okay, so for the spines, we are saving temporary variable s in axis.spines, and say we would like to print it. Print s. So what it will do, it will show that we have 4 spines: left, right, bottom, and top. So let's say we want to remove the top one and right one. This top one and right one. So how we will do that? There is a 2 method. One is using manually. So what we'll do, we will do axis dot spines, and from that object we have left, right, bottom, and top. So we will first accessing the top, and with dot again we are setting the visibilities. That also has a method set underscore visible and giving a false. So Boolean value false. So it automatically switch off that top right one, right which is fine. Okay. Similarly for top case, and if you now print the figure, then it will show that these lines are not there actually. It's removed from the plot. And sometimes we require that, but many people prefer this such a bounding box or the 4 spines. And another way of doing that, instead of manually, if say we would like to remove all the spines. Okay, so how we'll do that? So we'll directly define here which spines we want to remove and use a for loop. For s in say in list, we are defining, say we would like to remove the right, top, and say bottom one. And next, what we'll do, we are setting it manually. Instead of manually, in the for loop with the indentation here, axis.spines.s. What this s? This s is this temporary variable. First, it will set this to right, then it is top, then it bottom, and it will set the visibility to false. Same way. Right now, bottom has been off actually by the matplotlib because I have already provided the bottom. Okay, so that way you can do for everything. Like if we are giving the axis dot spines, all the spines lines are now been removed. Okay, that is also possible. So next, what we'll do, we will, in this case, we are just plotted the index values in x-axis. Right now, we are trying to plot a time series data. So the plot will be like this. Where is the PPT? So next, we will create a twin axis plot. What is a twin axis plot? That in one y-axis, we are want to add one type of data. In another y-axis, we want to add one type of data and want to compare that. And in the x-axis, we will try to add, we will use the time series data. Like say, if you are working in the environment department and you would like to see in one axis the CO2 level in million tons, and in y-axis you would like to plot say average temperature rise over the year. You can compare that what is the release of CO2 level and what is the temperature, average temperature increase on that year. That could be a comparable. And how to create that? It is called twin axis because in y-axis we have two y-axis. One is for y1, another is for y2, and y1, y2 are two different objects or two different variables. Here, like it is sales, and here it is ad budget. That is a data set. I will show how to create that. So for that, I have to read the sales data set. So from datasets folder, I'm reading the sales data set. I hope you have downloaded the zip file that contains also those data. And now I'm also adding that parse dates true. So what if it is a date format, the pandas automatically recognize it. And also I'm setting the index, this date column as our index. That date column exists in this data set, and that I'm directly setting as an index. So whenever you have to deal with such a time series data, putting the date column in an index will reduce your headache while plotting. So once I read that data and print the head, now you can see that the sales, ad budget, and GDP, these are the variables, and the date now been set as index of that data frame instead of the integer index 0, 1, 2, 3, 4 like that. Okay. Now we are going to plot this with first the sales and second is ad budget in y1 and y2, and the date would be our x. Okay. So how we will plot that? Same way. First, we have to initiate a figure and axis object, plt.subplots, figure size that is 10-inch width and 5-inch height. And we can also set here the DPI directly, but I would not recommend. It will cover the whole screen. Next, first we have to define the line one. What we want in the first, I will comment this out. This axis 2. Okay, so first we will try to see how when we will plot only the sales value, how it will look like. Okay, so first again we are using the axis.plot. We are in X now, we are giving the sales data dot index because we are giving the index values. Here index is date right now. Okay, in Y we are giving the sales. So this sales column values. The data would be sales data where we have saved the data, the sales data. Next, color, the line color will be that color of the plot or line would be blue. Label would be sales because this label is required to plot the legend. And we are setting the X label to time in years and setting the Y label to sales, and color would be blue. And the tick parameters I already showed. In Y axis, I would like to add the color blue. So if I print that or run this code, it will show this. This is the plot. Okay, in X axis, the time in increasing order. And this shows the fluctuation over the year because it is a line plot. That's why it is connected. And this sales, it is now in blue because we have set the tick parameter blue. Also the tick labels to be blue and the line also to be blue. Now I would like to compare what is the ad budget on every year. And I would like to put that ad budget in the Y axis, Y2. It is Y1, now it is Y2. So how we will do that actually? So the matplotlib also offers another function is called twin axis. Okay. So from that axis object, that axis already we have created. We directly use that dot twin x, that is create a common x for two y1 and y2. Okay, and we are saving this in ax2. That is our new axis, that where we will plot the y2 values, not y1. Y1 already plotted. Okay, so axis, from that axis object we will take the twin x such a function or method, and we are saving in axis 2. Now this axis 2 will be our new axis where we will plot the y2 values. Okay, so again the plotting mechanism is same, just we are, instead of earlier we are accessing the x axis, now we have created twin axis and we are accessing the x axis 2. And here again we are using the plot sales data dot index in x, and now add budget column in the y axis. The sales data set is the data set. Color would be, now we are plotting this color as red, the line color will be red, and we are adding a label add budget. Again we are setting the set y label with set y label in axis 2. The add budget would be the y label will be add budget, and color will be red of that label. And tick parameters, now we are setting the tick parameters of the y axis to be red. And now right now don't consider this one and this one, and we will run that. Now it automatically plot the y2 axis, that is add budget. Now you can compare, if it is not like that, it is very smooth, then you might have able to see that fluctuation in every year, what is the sales and what is the add budget, how they are changing. It is very much useful. I have used that while plotting the time series data for environmental data set, like a CO2 level with average temperature increase, one example. Okay. So next thing, we don't have a legend here. So here in twin axis case, the legend, putting the legend is little bit tricky, but I have that code. So here for adding the legend, we have to add both. We have to save those plots. The first plot I'm saving in L1, and in second it is L2, that line 2. And then again I'm creating saving those objects together in a lines. We can save those together also. Okay, because it is a class object, we can also save that as a lines. And after that I'm using a list comprehension for L, for each line in the lines. First it go to the line 1, then it will go to the line 2. And what it will do, this from that L, what is the temporary value, from that we are getting dot level. Okay, so what I am doing, saving the two labels, adding these two labels and saving in a lines. And then I'm iterating through those lines, line 1 and line 2, and getting the label using the get label and using it as a list. And after that, axis has a legend function. So axis.legend, in that I'm giving this lines, what would be the lines. So it will take the line object, and what would be the levels that I obtained from the list comprehension. So levels. And if I want to save that, so figure and save fig again with images folder / twin axis underscore plot.png, that would be the name, and DPI is 300. So what we'll do, it has added a also legend. So blue one is for sales and red line is for add budget. I hope that is clear how to create a plot like this. And we will take a short 10-minute breaks, and then I will start the session for bar plot, and we will enter to the statistical plots. And that would be a little bit extensive because I will show different way of doing the plots, like matplotlib way, then direct using the pandas data frame, and also using the seaborn and pandas data frame. Okay. We will take 10-minute break. If you have any question, you can plot, you can post. Sir, can you please add the comments with your code? What that mean actually, Devender? Comments with your code means? Okay, we'll start our session from 11:55. Okay. Okay. Yes, Devender, it has been already added as a comment. You can uncomment it if you'd like, but the comment has been added. This comment actually used to convey some information. Like I have commented here, like set axis level. It is just a text that will not evaluated while running the code. So our interpreter, Python interpreter, will ignore that one. That is for just giving information. If I have to share this code someone, what this thing things does, that I have added with a comment here. Set the y-axis levels. What it does, it set the legends. What it does, it create a plot in the y2 axis. Okay, here I'm written GDP. It should be say ad budget. Earlier I have tried with GDP, so it would be ad budget like that. I hope this answers your question. We'll start at 11:55. Okay. Yes, you can plot any number of points in line plot until unless it won't too much clutter your plot. Okay. So if there is a clutter, there are different methods to remove that. There's no restriction on the number. Even I have created plots where the points are in millions. So matplotlib able to handle up to 10 million to 12 million points. Okay, but for that reason you need it will clutter the plots. So there are some methodologies are there using which you can actually remove those clutters. It is called overplotting. When you will plot so many points that you're not able to look at which one is what, then you have to take some methods to reduce the number of points or to make improve the visibility of the points. That I will show during the scatter plot. Okay. So it is 11:55 and I will resume the session again. I hope I'm audible and my screen is visible. So next part is bar plot, or this is a bar plot, but it's a dodged one because uh, there are two things we are plotting, like for here in X. First, let me define what is bar plot, then I will show this. So a bar plot, nothing but a plot that shows the relationship between a numerical variable and a categorical variable. Here the categorical variable is sex, female and male, and the category and the numerical variable in y-axis, that is a percentage here. It could be count. So basically it is used when we would like to show some count. Let's say in our tips data set, I would like to know how many are Sunday, how many are Tuesday, how many are Thursday, like that. And I would like to plot that using a bar. In bar, you can plot those like the Sunday contains 60 observation, the Tuesday contains 30 observation, like that. And sometimes in our research work, instead of just a single variable bar plot, we sometimes compute the proportions, and we would try to use many places. I have seen that people use a pie chart to represent the percentages. But sometimes bar plot is more appropriate when you have large number of, say, categories. Let's say I have a variable which have 50 categories, and in 50 categories have a repeated values like categorical variable, and 50 categories, and you want to know the count for each category. So if 50 category, the plot which contains such 50 category, it can't be presented with a pie chart. So that case, a bar chart is much appropriate. Let's say, for example, I would like to know in our tips data set, within the sex category, how many percentage are smokers, how many percentage respondents are non-smoker. Okay. So for example, if I have to know that, I can present using a bar plot, and this bar plot is like female contains say 62% are non-smoker, 37.93 are smoker. Similarly for male, it's very easily visible because as a human being we are terrible at seeing numbers. So visualization should be appropriate while presenting your data in a research, say while writing an article, while presenting in a presentation. So how Matplotlib create these bars actually? These are some sort of rectangle. You can see that given up that is ranging up to a certain value, showing that it is contains that percentage. But how Matplotlib does that? So that would be in this session, and this session I will start with that only. So for example, let's say how the bars are represented in Matplot using Matplotlib. To do that, I have to import from matplotlib.patches. The patch means this rectangles actually, that patch object. This patches contains a rectangle module. So we will import from matplotlib.patches, import rectangle. That will be helpful. Like in line, we have imported the line 2D. Here we are importing the rectangle to represent a rectangle. What it contains, you can see if I hover that, it will show that XY objects and how these rectangles will be represented. This is the height, this is the width, and this is the 0 XY coordinate from where it will start, like this. Okay. So first we have to instantiate a object, figure object and axis object. Here I'm not giving any figure size. It will take the default figure size. So after instantiating, I have to create two rectangles. First, say I would like to create a rectangle 1, and second I would like to create a rectangle 2. So we have already imported the rectangle. Okay. And in rectangle, it takes a XY value where it will be plotted, the width of the rectangle and height of the rectangle. Okay, because we are on a bar. So inside the rectangle, first we have to give the XY location. It should be plotted in 0.1 X and Y should be 0. And the width would be 0.2 and height would be 0.9. Similarly for rectangle 2, it would be 0 location X 0.5 and Y is 0. And the width would be 0.2 and height is 0.5. And next we have to add those rectangles like we have added the lines in axis object. So axis also contains a dot patch object because we are adding this as a rectangle, we have to need this as a patch object. So add patch rectangle 1, add patch rectangle 2. You have to run that code. Now you can see that at point 2, now at point 1, it has started the rectangle. It went up to 0.2 because width is 0.2 and the height went up to 0.9. So 0.9. Similar for rectangle 2, it's starting from 0.5. So it started from 0.5 up to 0.2 width, and its height is around 0.5. Okay, that way in background rectangle been plotted by matplotlib. When you give the real world data, that way it will in background does the thing. So you need the basics, how it, this is the basics actually. So how matplotlib plots the bar. So once you add this axis objects using the add patch object, you can also inquire that whether this patch object exists in this axis, this patch 1 and patch 2, a rectangle. We can directly inquire with the axis.patches, like we are inquired about axis.lines. In rectangle, it's called patches. Now you can see that axis.artist list of 2 patches because 2 bars, it contains 2 bars. Okay, I hope it is clear. Next, let's say I would like to change the color of this bar number 1, not 0. Same way we have that time we are accessing lines. Right now we will access patches. So axis, then patches, and this patch number 1, and set the color to red. And if I print the figure, it will show that it has set to red. Similarly, let's say instead of this way, we have a list of data and we would like to plot. So axis object, last time we have used this plot method to plot the line in axis. And now we have to use the bar method. The axis object also contains a bar method. Okay. So first we are again defining the subplots that will return figure and axis. Right now we are giving the x values, x coordinate, where it will start x values 0, 1, 2, 3, 4, say, and y values up to which the rectangular will go, this height, say 1, 3, 5, corresponding to every x, 2 and 7. Now what we'll do, directly we can create a bar plot. We don't have to go this way. This is just to illustrate how it actually adds the values in background. So axis.bar, and inside that you have to give the x values and y values. And if you run that, it will automatically plot. So whatever the range we have given at x0, it is plotted as 1, then it is 2, 3, then it is plotted 5, 2, and 7 height. So this way we will plot. And this could be this, whatever the y value we have given, it could be a count, it could be a percentage based on your data. So let's check the axis.patches object again. So this axis.patches contains right now 5 patches because 5 rectangles 0, 1, 2, 3, 4, or if I count normally 1, 2, 3, 4, 5. Okay, so 5 patches. Let's say I would like to change the third patch. Okay, so 0, 1, 2. The fourth patch, say I have written here 4. So this one. So 0, 1, 2, 3. This patch I would like to change to a red color. So again, axis object inside that patches, and as it is a Python, so index starting from 0. So 0, 1, 2, 3. 0, 1, 2, 3. This one we would like to change. So we are accessing that object and setting the color to red. And if I add this, it will change the color to red. In that way, actually, in using the matplotlib way, we can directly create a bar plot. Okay. Now I will go with a tips data set and show you how a real world in research we will do that. We will try to generate this plot. This one. We'll try to generate this plot where the x-axis object contains the sex, female and male, and inside that it also contains represented with yes, no, whether the person females are smoker or not, or males are smoker or not, and we will count and convert it to a proportion that what percent of the females are smoker or what percent of females are non-smoker. Similarly, for male case, what percent of males are smoker, what percent of males are non-smoker, and we'll represent it with a percentage. Okay, and this is called a bar plot. It instead of male and female, it could be day. Like in our tips data set, 4 days are there, so there will be 4 pairs if we change that. So how we will do that? First, let's start with the data set. I'm importing the tips data, and here first we need to compute the proportion. How we will compute that? Okay, so I have already discussed about the group by methods. Okay, so tips data set, then dot group by. We are trying to compute the percentage within the group of male and female. Okay, so in male and female, how many? In male, how many are smokers and non-smoker? In female, how many smokers and non-smoker? So first we have to divide the total data into a group. That is our sex. So group by, we are separating the data. I've already showed the group by method. I hope you have gone through that lecture notes. So in tips, first we are separating the data using sex. Then the data is separated based on female data set and male data set. And inside that, each data set, we are asking the pandas to return, take a particular column, smoker. Okay, so first it will, what it will do, it will separate the data set into sex, male and female. Then from sex data set, male data set, it will take the smoker column. Again, from female data set, it take the smoker column. And then we will apply a value count. So that means for first say it taken the male data set and taken the smoker column, and it will try to count in male data set how many are smoker, how many are non-smoker. Similarly, in next group, it will go to the female because sex is female and take the smoker column. It will try to count for how many are smoker, how many are non-smoker. So group by, so value counts. It will give us the count. Now you can see this, see this in sex female, the smoker status no and yes. How many counts are there in our total data set? Similarly for male, no is 97 and female and yes is 60. We have also functionality to convert it to a proportion. So normalize equal to true. So it will convert to proportion. Now it is in proportion, but we want it in a percentage, 100%. So what we'll do? We will multiply it with 100 dot mul 100. So it is now converted to this, but we want to reduce the decimal place. So dot round up to 2 decimal place. So it is up to 2 decimal place. So among female observation, non-smoker around 62.07 and smokers are 37.93, like this. And that thing, whatever it is returning, it is in a index pair. This is an index like sex and smoker. So what we can do, we can use the dot reset index such a method so that it will convert to a column. If you would like that way. Okay, I hope it will return. No, dot reset index method will not work here. So in matplotlib, we need this in index and it's a column pair. Okay, so whatever it is returning like this: index sex for this sex2 category, and smoker has different categories and the proportion. So there is another method called unstack. What it will do, it will this smoker no and yes status, it will create another column and put it there. So unstack, what it will do, I will show. Right? So what unstack what it actually does, it will create the sex column or sex observation, that is our unique observation, female and male, put it into an index, and the smoker which contains no ns, it created this smoker no ns as a column. Okay, and all the proportions as a value. So for sex female, the no is 62.07, sex female, the yes is 37.93. And this formatting is required for matplotlib, not required by Seaborn. Okay, in Seaborn you directly give the data set. So just I'm showing how it actually done by in the background by the matplotlib library. So we have, if I don't unstack, what it happened, it creates like this: sex, female, male, and smoker categories and percentage. If I stack, what it happens, that smoker no and yes category is converted to a column, and the sex is defined as the index. Now we will save that in this return object, this thing, and we will use this to create our bar plot. Okay, so we were saving this in df, and if you print the df, it look like this. Now we will start with our bar plot. Okay, creating a bar plot. So one by one I will go. So first we have to define the figure and axis object. So plt.subplots You can give a 1 1. If you don't give a 1 1, that is also not required. So figure size 8 6, and we are saving the axis object and figure object, and we are also defining the width of the bar should be 0.2. I think I have okay. So next thing, what we have to do, so we have defined the figure and axis objects, and the width of the bar has been set to 0.2. Next, what we'll do, we create the first rectangular bar. Okay, so how we will do that? This way. So first assume that 0. This divide by divide is not there. Okay, so minus width also I will not give. Okay, so axis dot bar. Okay, and to run this. Okay. I need this thing actually. By mistake, I have put this in bottom. We also need that here actually. Okay. Just let me run this one time. Okay, let me see if there any problem is there. And then I will show. This happens when you will do debugging or create plot. These things happens. So now it's 0 1. Now we can set the labels, female, male. Okay, now it's functional. Okay. Let's go one by one. Okay, before starting the plot, what we have to do, we have to first define the figure and axis object. So plt.subplots, figure size is 8 inches width and 6 inches height, and width is 0.2. So for each bar, the width should be 0.2. Next thing, while defining the plot, first we have to give for the no cases. Okay, so we have already the data for no column. We will plot the female and male proportions. So how we will do that? So we have a option for axis dot bar. Okay, and first we ignore this thing. Okay, so let's say I'll remove this one right now, just for understanding how it is plotting, and also for this one. So first we are adding the bar. So first we have to give the X position. So how we'll get this X position? Because if you try to plot without this X position, it will not give the plot or not able to identify the X location. For that, I have created, I have taken the data set DF, and from that I have taken the index values. So whatever the index, female and male. Another I have created np.arange. What will actually does, it will print the range. The first one is 0 and second was is 1 because it is index level. And if I print both of them, so first is the index, that is our labels. So label is female and male. Okay, so it is the index values df.index. And next thing I have created np.arange, so it will go up for that as a range. And using the length function, inside that I have given the label. So label contains two things, female and male, so it will count 0 and 1. And when using the np.range, so it will giving a range from 0 to 1. Okay, so let me print this. If you don't understand what is this length actually doing, length is returning us the length of the label 2. Okay, so here the arange function, it is excluding the right side end. So we are starting from 0 1 and 2. So it will ignore the second index and return 0 and 1. So what we are doing here, np.arrange length of the label, that is contain 2 because it contains 2 object, the df.index, and it returning us this as a list 0, 2, 0 and 1. Why we need that? Actually, that would be the question, why I'm struggling with this thing. Because while giving the input of the x-axis, if you don't give this actually x-axis, it will not able to plot. First we have to give the x-axis object this x values, this 0 and 1 as a numeric value. If you not give numeric value, it will not able to locate the axis location. So based on that, we have to give the first in bar plot, we have to give the x, and then we have to give the what will be the y. So for the y values, we have to give this. First we are giving the no column that contains for female 62.07 and 61.78. Okay, then width, that is the bar width, we have defined 0.2. Label would be no, and the edge color. Edge color means that whatever the bar, it will put a edge color of black on every bar. Okay, and next we are doing with this next bar, that is next column of our yes column. Okay, so what is the yes column? Yes column is also contain how many are smoker, female and male. That is here same way, axis dot bar. In x we are giving this representation 0 and 1, and also df equal to now yes, with this width, label is yes, and edge color is black. And if I plot this, what it will do, it will giving a plot like this. Why it is giving a plot like this? Because it is imposing, because we are giving a 0 value and 1 value. Okay, so whatever the for yes case and no case, the bars are imposed one over another. So first the blue one is behind the orange one. Automatically what it does, it pastes the orange one in front of it. So what we have to do, we have to shift this orange one by 0.5 right side and 0.5 left, and this blue one to 0.5 left side. So it will be stacked side by side. That's why I have done here minus with divide by 2. So it will plot this blue bars 0.5 left side. For this blue bar 0.5, this blue bar 0.5 left side. And also I have added here with divide by 2, 0.5, that is our width, whatever width, it will 0.5, add that 0.5, and this orange bar will be shift 0.5 right side, and this orange bar will shift 0.5 right side. Now if we plot this, now you can see this that in 0 it is shifted at 0.5 here, and it is shifted at 0.5 right side, both the bars. Blue bar shifted 0.5 left side, and the orange bar shifted 0.5 right side. So now it is stacked. But if you see the labels are numeric. So what we have to do, we have to set the label. So we have already created the label that contains female and male. Okay, so what we'll do, we'll use the axis.set x ticks, because we want to set this x ticks. Okay, so we are giving the x, and this x contains what it contains. We have already defined 0 and 1. So it automatically add this to our plot. So 0 and 1, but we don't need 0 and 1. We want label, female and male. So what we'll do, we have already created the label also here. So that is the label that contains female and male. How you get the label? From df.index. This index contains the female and male. And now we will again set the x-axis tick label. So axis.set x-axis as a tick label, x tick label. And here I am giving the label. So now we have get the final plot where it is female and male. Okay, so now how many patches it has? Anyone in the comment? Because each bar is a patch. So how many patches are there? There must be 4. Okay, 0. When you plot this kind of group, because we have added the no case first, no columns, and then yes column. So no column contains this blue one, yes column contains this orange one. So it patches, the patch contains, it contains 4, but this patches number or sequence will be 0, 1, 2, 3, like this. So first it will count for the blue one, 0, 1, and then 2 and 3 is for orange one. If you want to access those patches or access those rectangles. So it contains, if I print the patches, it contains 4 patches, and this patch means this each rectangle contains different attributes. What is the height? What is the location of x? Okay, so how you will get that? Say this, you want to access the height of this first patch, 0. Anyone in question? 4. Okay. So how I would access this height of this patch? Because I need this height when I want to put a label. Sometimes in bar plot, we want that label. What is the label here? Say 60.1%. I would like to put it here. Whatever the label, I would like to in percentage. Whatever the label here, I would like to add a percentage. So this axis object also contains defined methods that will return you the value. So we have 4 patches, but I want the height of the first patch. So what will do? Axis dot patches with indexing method, the 0 patch, that is this bar, and I will use the get height method, and it will show me the what is the height, 62.07. So 62.07 was in our data set, 62.07 for no case female, the first bar, this one. Okay. Now the thing is there, we can get every bar, every patch object's height, and also X position, Y position, everything. Okay. So that is very much required when we want to add some label. How we add the label then? So let me show you how to add the label. So comment it out. This part is crucial because every time you create a plot, you have to add the label. If you are you want to add the label for a bar plot or say pie chart. So this is very much important. Just let me show you how to do that. So first we will use the for loop to go through each patch. How? First 0 patch, 1 patch, 2 patch, 3 patch, and retrieve the heights. And I will use the annotate method to annotate at a particular height. Okay, so how to do that? Let's do that. For P, for every patch, that is our temporary variable in x-axis dot patches. Okay, so go through each patches and save it in P. Then I will annotate. So annotation will be saved into T. So axis dot annotate option is there. I will copy it from here rather than typing. So axis dot annotate method is there. And how we will annotate? Because if I would like to add some percentage or other thing into value, so we have to convert it to a string formatter. Okay. So this annotate method takes first the value, height of where we want to plot or annotate that value, and the X and Y coordinate. So what it takes? It takes height, then in a tuple X and Y coordinate, X comma Y. Okay. So first I have to give it as a string because I want to add a percentage symbol to that. So str function inside that. So we are iterating through each patch. So first patch say p dot get height. Okay, it will give me the height. Every time it will go through each patch 0, 1, 2, 3 like or rectangle, and from that object it will fetch the height from this p object. Okay, the temporary variable. Next, what we will have to do? We have converted to a string, and after that, we would like to add a percentage. Why we have converted to string? Because we want to add the percentage symbol. So percentage. Okay. So next, we have to give the xy coordinate. So xy will be first. We have to give the x. P dot get x method is there to access the x value, comma. Then p dot get height. Okay, another method is there. And then what we'll do, whatever the annotation we are getting, we also change some part of that. T dot set, we would like to change the color of that. So color of the annotation will be, so first it will access the first object, first patch. It will get the height and put a percentage on that, and it will return that height, and this height object will be as annotated. And where it will annotate? XY coordinate. First it will get the patch object's X position, say for this X position, and then it will get the Y position. Y position is the height. So here it will add the annotation, that is this is the height with a percentage symbol. Okay, so color we will set black and say size equal to 14, and let's say print the figure object also fig. So now you can see that it has added, but it is imposed somehow and it is left little bit left. So you have to do it manually. So let's say I want to shift little bit. So I would add say 0.03 plus 0.03 in the X, and also the height I will add, I have added 1. So say whatever the height I'm getting plus 1. So now if I print, let me run it again because it is imposing the plot. So let's create the plot, refresh plot. And now if I impose, now it is good. 62.07 here, 37.93%, 61.78, 38.22. Okay. I hope this is clear till now because this part is very much important. If you understand that, you can annotate any plot anywhere because everything is an object in Python, or you can access the values. Like I accessed the patches, first of patches, and then annotated that patch, second patch, third patch, fourth patch, and annotated the percentage values that our data set has. I hope it is clear here. Now we will remove the spine lines. Same way, go through the top and right using a for loop and axis.spines. We set the S, that is our top, and set the visibility false. It will remove the top line and right line. That is same. If I plot this, that is now gone. It is little bit bold because I am imposing. It will every time you will run this again, it will impose over that. So you have to freshly create the plot again. Like this. Next thing is customizing the plot. Again, I will run this so that it was fresh. The customization part is changing the tick levels that I've already showed you. That axis.tick parameters, that this ticks, I would like to change the size. So level size is 14, and level rotation. You can also change the level rotation to 0. Here, if we plot, it is already 0. You can also change the, let's say I would change it to 45 degree. So X tick, what is the tick parameters in axis? It will automatically change it to 45 degree. Then we are setting the axis.set Y level, that is percentage. So Y level would be our percentage, and the X level will be 6, and the size will be 14. Next, what we'll do, if I use the axis.legend, it will return the default legend like female, yes or no. But let's say I want it is say N or yes, Y. We can also do that. So we will modify inside the legend. There is a method or there is an argument called labels. Inside that, as a list, you have to give the what is the for first. First is no case, and yes case is second. That is our red ones or this orange ones. So yes, no, and yes. Font size will be 12. Title would be smoker of the legend, and title font size will be 18. Now you can see that smoker legend has been added. N represent no, and 1 represent yes. And now you can see that it is in angle because we have set tick parameters. If you not give the axis equal to say Y or X, say we want to change it for Y axis. And if you now run this, it's already actually imposed. So let me run it fresh from the top. Here, let's say I would like to tick parameter axis Y. Okay, only for say for X, I would like to change. So now you can see that the tick levels are horizontal here, but here for the tick level for Y has been a 45 degree angle. You can also change anything. Anything is customizable actually here. Next thing is, let's say this legend has been added at the bottom, but I would like to change the position of that. I don't like here. I would like somewhere here in the middle. So axis object also has a legend of legend. Axis object legend also has a method called set B box, that is boundary box, to anchor where you would like to anchor it. So axis.legend underscore, because we are accessing the method inside that, and set B box to anchor. So the X position is 0.6 and Y position is 0.5. By default, matplotlib takes it as 0 to 1 and 0 to 1. Okay. And if I print the figure again, Now it is in the middle position. You can change again if you would like to plot it in say 0.7 or 0.8 height. That could be possible. And again, the saving figure is same in the images folder. I'm naming it as dodgebarplot.png and DPI is 300. Okay. So any comment till now? Tilt code show once, please. I missed due to network. Tilting code is nothing but this setting the tick parameters. So axis dot as a tick parameters. Here I'm giving the axis X that I'm asking the matplotlib to alter the X axis tick parameters, and the labels is level size is 14 and level rotation. Here level rotation is 45. So level rotation is 45, female and male. And then I'm saving this figure. I hope this clear. Next, I will show the same thing with that I showed using matplotlib. Now I will show it with pandas. Okay, so in pandas data frame, instead of this way that we have done, that is creating first for no, then for yes, that is very much excess code. Sometimes we don't like that. And that way comes the pandas method. Pandas library also supports matplotlib plots. Okay, so same way, same thing we can plot using the pandas. So how we can do that? First again generate this. This already we have generated, like sex, female, male, and smoker, no, yes, and we have saved this in DF that contains the proportions. So how the pandas plot actually? So our DF object contains, it is a data frame object, contains this as a sex as an index and smoker, no, yes as a column. We can directly give it to a plot function and define what kind of plot we want to plot. So figure, axis, plt.subplots, defining a new figure object. And again, what we'll do here, just let me write it so that you understand. So we have this df object for pandas method, df.plot. What it actually does, it will plot a line plot by default. But what we want a bar. So what kind of plot we want? So bar. And with comma, axis where we want to impose it in axis, that is we have created, and comma, then edge color it will be black. So I print that this plot is directly created. We don't have to do that much customization. Okay, it's very easy. In one go you have created that. So the customization will be same. Here you can see that by default it is plotted the labels of the x-axis vertically, like female and male. That's where it is very useful, where we have set the tick parameters. So level of rotation. Here you have to define now 0. Otherwise, what we'll do, it will plot it vertically. The same way we have already created this plot. Same way the customization is same. First we annotate. The annotation method is same. Go through the each patch object and convert it to string and add a percentage and xy position. At xy position, add that. Then removing the spines. Then leveling. Now we have that set the level rotation to 0 because we don't want it vertical, this female and male. And again the legend, say let's say I want n and y, or instead of or say capital no or yes. And then again that legend b box location is 0.53. So if I plot that, done. So I hope the methodology I am adopting here you are able to understand. So everything is customizable using matplotlib, and that is the beauty. Anything you want to add space here, it is possible. You want to reduce the space, it is possible. You want to reduce this space, that is possible. And you want to increase the space between this line and this female, that is also possible. You want to change the axis, like this x-axis should be y and this y-axis should be x, that is also customizable. I will take 2-minute breaks, then I will start with the Simon style, or let me show this Simon style, then we'll take the 2-minute break. So two way I have showed. One is matplotlib way, where we have stacked using this this method, where we define the first for no, then for yes. That is very much difficult. Sometimes it is not easy to understand. Next, I showed you that directly using the df.plot plot and kind equal to bar using a pandas method. Third, I will show you that how to do the same thing with Cbond. In Cbond, you don't need actually, okay, don't need in the data frame like this, like sex should be in index axis or index values and smokers no yes should be column. In Cbond, we directly can provide the data. So let's create the df1 equal to in bracket. Okay, so tips. So here we need only a column in as a data frame. In Cbond, always accept data frame. So we don't need a index column or a particular category as column, category is yes, no as a column. We directly create a percentage column. How we will create that? Tips dot group by, then sex, that is our grouping variable. Then we will take the smoker column from each group and then dot value counts and normalize it to make it a proportion. And next with dot multiply it with 100 to make it 100% and rename also it so that this new column that will create that column should be our percentage percent. And we will what will return, let's see, because we have saved in df. So what will return? Df1, it will return like this. Then we will what will do, we will reset index. Okay, so reset index, what will do, it will convert that while reset index is not there. Let me show it again. So it was in like index sex and smoker. Now we would like to take it as a column. So reset index, what will do, it will reset the index to 0 to put an integer value and make this index as a column. So now sex, smoker and percentage, corresponding percentage is in a column. And that's what how that's the thing we need, just a data frame where the each observation should be in cell, each value should be in cell, each observation should be a row, and each feature should be a column. Here the percentage is also added as a column. So sex, female, smoker, no, percentage this. And we can also add a round function. I've already added here, I guess. If not, then you can also use the dot round. So it will reduce the decimal point. It's clear. Now for plotting as for Cbond, Cbond has two specific great method. One is called cat plot for categorical plotting, another called real plot for relational plotting, like numeric variable scatter plot. So with categorical plot, you can plot any type of a categorical plot. And here I will plot a bar plot. So Cbond has a cat plot function. So already we have imported the Cbond as SNS. So dot cat plot, and inside that we have to give the values. So first in x-axis we want to plot this sex column. In y-axis I want the percentage values. Hue means color. So smoker, no or yes, these categories will be defined as color. Say no for blue and yes for orange. Then kind, what kind of categorical plot I want? It is a bar plot. Then data is equal to df1, that our data set. A legend equal to false. I don't want legend. Press Ctrl Enter. The plot is ready. Okay. And the customization part is same. This customization part I will not repeat it again. But one thing to note that the cat plot object does not require an axis object, figure or axis object. I haven't defined it here. Why? Because cat plot function does not take axis object. So for customization, how would I know how would I get the axis object? Because I need customization. I would like to put here values. I would like to change the fonts, the color, but it doesn't support axis object. So I haven't defined the subplot which returns the figure and axis object, and I haven't included the axis object. So matplotlib has function which also at particular instance. Right now we have created this plot. This plot is in this environment, and the matplotlib has a functionality that will return the axis and figure object. So axis for this plot, I would like to take the axis, whatever the axis. So plt dot gca get figure object plt dot get current figure gcf. Right, add those things Now I have this axis object and figure object. Voice is breaking. My voice is clear right now, everyone? Anyone having problem? The Abhishek Pandey. If your voice is breaking, then you should reconnect or check the internet. Okay. So the current plot that doesn't accept the axis object, after initiating that plot or running that plot, I can also get the axis and figure object using this method. Get the current axis, get the current figure. And now we can alter anything I want in this axis object. So again, this thing, again, I got the axis and figure. And here is the customization part. Customization part is same. I will not repeat it. Adding the annotation, adding the labels, adding the or customizing the legend. And because we haven't given a figure object, we are not defining the subplot and not returning it axis or figure normal way, and we are not defining the size. At the end, what I did, the figure object also contains a function called sets size inches. So whatever it will return, I would like to also resize it. So the figure, we have already got the figure object from here, plt.gcf for the current figure. And at the end, what I'm doing, figure.setSize.inches, 8-inch width and 4-inch height. So if you add this, it will do the same thing. So three-way we can plot the bar plots, like for using matplotlib, using direct df data frame or pandas dot plot method, and using cbond. Same thing. Same thing can be achieved with multiple way. Various plotting libraries are there, and matplotlib is the base, even for the cbond. I will take 5-minute break, then we'll start with the stacked bar plot. Stacked bar plot is nothing but instead of side by side, we will impose it is like one over another and make it 100%. Okay, so the total is 100%. It will stacked. For female, how many are smoker, non-smoker, how many smoker? For male, how many are non-smoker, smoker? So how to do that, we will see in after next 5-minute break. So we'll start. Yes, it's clear. Okay. So we'll start after 5 minutes. These are the things I'm showing because sometimes you wondering why it is so complex. It's not complex. You haven't go through ever. You are learning for the first time. So same thing could be done with multiple ways, 10 to 12 ways, 10, 20 ways I can create this plot. Even with defined as a functionality, I can change different customizations as per my need. And as per your need, you can do that. That is the beauty of Matplotlib. And that's why I'm teaching Matplotlib, not directly Cbond. So you should know how the plots are created multiple way. Whatever your preferred choice, you can adopt that. Nobody will stop you. Nobody will question you while you are generating a plot and putting in your journal or your thesis. What tools you have used, nobody will question. So whatever you are comfortable with, you should adopt. Okay, we will start after 5 minutes. 48, and this lecture will go up to 1:30 because I would like to complete this, at least the stack bar portion also. So bear with me. And if there is any question, you can paste. We will start at 12:48. Okay. Again, I will show the stack bar plot in 3 ways: Matplotlib, Pandas, and Cbond. Same way. Just small tweak and nothing else. Same everything. So let's start the session. It is 49, I guess. And in this session, we will learn. I hope my voice is clear and screen is visible. Please post someone in the chat box so that I will continue. Anyone, please post whether I'm audible and my screen is visible. Okay. So now I will start with the stacked bar plot. There is a little bit noise. So let's start with the stacked bar plot. So stacked bar plot is a bar plot that is stacked over one over another actually. Okay, so let me show you how it look like. The same plot now you have stacked. Instead of side by side, it is called a stacked bar plot because it is stacked. The yes cases are yes percentages stacked over the no percentages. Okay, so it is total 100%. Sometimes we need this kind of plot to show the proportion or share for something. Okay, so first I will show you with the matplotlib style. So matplotlib style, we have already shown you this. We need the data format like this, where sex should be index and smoker no and yes column should be our columns. So to generate a stack bar plot, how we will do that? So first, let me comment it. First, we need to initiate the figure and axis object in matplotlib way. plt.subplots figure size 12.6. And to add a bar, again axis.bar. Okay. Earlier we have used, I guess, for matplotlib style, axis.bar, same. Okay. So this time, axis.bar, again we are giving the df.index. Here we have to give the df.index. What is the index contain? Female and male. And the df is for no. First we are plotting the no cases. Okay, so 62.07 and 61.78. So in x-axis we will give female and male. In y-axis we are giving the first no column and labeling it no, and width is 0.3. Okay, and let's comment it and let's print it. So it is plotting the first one, no cases, and for female and male. Now we have to stack the yes cases over that. Wherever the male cases ending, like here for female cases, female and male cases, for no cases are ending, like the height is here 60 something and here also 60 something. Over that 60 something, we have to impose the yes case, yes percentage. Okay. So we need to have this location where we that would be the x and y coordinate. From here we have to define the x and height of that bar. That would be the x for that. For female cases, if we want to impose the yes cases, yes percentage. So where we have to impose the y location here, like at 60 something. The x should be same, but y should be this one, that height. That would be the base for that yes percentage. Okay, so while adding the yes case, so df.index and defining down the taking the column yes, and bottom we have to define the bottom. What do we do the bottom? Where will start the yes? Whether should I start the yes cases percentage from here? No, I want to stack that over this bar. So it should be started from where the no case end. That height should be the start of the yes case. So df.no. So earlier the df.no is this one, and where we'd like to add this yes percentages over that as a no case. So the bottom where it will start at the top of this bar. So this top bar is the height for the no case, that is we have already plotted. That's why you are giving for yes case the bottom where should I start the bar. It is not here, should be here, and this height is located inside df.no. That's why you're adding that bottom equal to df.no. And then label yes with 3. And if I print that, now you can see that it is added over that. Okay, at that location. That is the trick, just to create stack bar plot. And everything is same. The customization part will be same, little bit tweak that I will show. So next thing is that for adding the bar values, earlier it was dodge side by side. That was easy, going 0, 1, 2, 3 like. But here it is stack. Contains in our matplotlib. This blue one, that is for no case, that we have stacked, that is kept by matplotlib in a container. So whatever the value associated with these blue ones, like for no cases for female and male, it is contained in a particular container, and this yes case that we have separately given, it is also contained in a container. So if I access the container, the access method has that container, so access.container. Now we can see that bar container object has 2 artists. Bar container object have 2 artists. So it is a list inside that, giving the first one contains 2 objects, this blue one for male, female, and blue one for male. And this also contains 2 artists. One is for orange, this one, and one is for male, orange, this one. So if I would like to see what this container contains, the 0 container and the 1 container. Okay, so first I will use the access.container and then index out the 0, this one, and then this one, 1. And if I print that, now you can show that bar container object have 2 artists. So this container contains 2 objects, this 2, and the next container, the 1 container contains these 2 objects. Again, I will go inside that and see what is this container, sir. So I'm going to the first container, taking the first container and taking the first bar, second container, the first container and second bar. Again, the second container, that is our index 1, the first bar 0, and again the second container, that is our index 1, and taking the bar number 1. And if I print, now it will showing me different properties that bar has. The bar XY coordinate, width, height, and angle. And I need this 62.07, 61.78, 37.93, and 38.22 that I would add in our this stacked bars middle, like this one here. And how would I do that? So this access container, just see the hierarchy. The access container contains 2 type of container, for the first no cases and for second yes cases. Okay, this container, each container contains 2 bars, blue one 2 and blue one orange. So total 4 bars, and all these 4 bars are like this. So first one is 62.07, 62.07, and this one the second in the first container, second object or second bar, so 61.78. So these 2 height, and these 2 height also contained by the second container, that is our 37.93 and 38.22. So 4 containers are there. Okay, and now how I would to access these values, how we will do that. Earlier I have shown using the patch mechanism. Here I will show using this container mechanism. So first I will go through a loop. That is the most important part. The rest is same. Okay, so for C is the container, that is a temporary object in access.containers. Okay, containers, that is our, I'm going through each container. Then what we'll do, I will print using a list comprehension. And inside that, what we'll do, I will run a for loop, because I'm using a for loop to access the first container, second container. Then inside that container, I have 2 bars, each container. So again, I have to write another for loop for the V in C. Okay, so go to the first container and again loop in the first container and take out the values for first bar and second bar. Okay. Then what I will do? Then I will check whether the container height is there or not. Sometimes you have a bar plot where the height would be 0. Let's say this bar has 0 height. This orange one is not there. Only this contains a 0 height. Still, it will, when we are adding annotation or would like to add the percentage value, still it will plot a 0%. But sometimes we don't want that. So for that, I can add a condition here. So first I'm accessing the containers, looping through the container 0 and 1. Then again I'm using a for loop, and inside that first container I'm accessing through the bar 1 and bar 2. And again I'm giving a condition if V, whatever the bar that has a get height method, height is greater than 0, then only return me the value. Okay, return me what value? This v dot get height. Okay. Else what will do? Else return me a just blank container, each container 0, container 1. Again, under this container, iterate through each bar. And if the bar has a height value greater than 0, then only return this, else return a empty string. Okay. So somewhere it is wrong, where if v dot get height greater than 0, okay, else condition, else. So go through each container, under each container also go through each bar, and if the bar value is greater than 0, then only return the v dot get height, else return an empty string. Okay. So if I print that, it will show me a list, and I can use a round function here to round whatever it is returning the height to a 2 decimal place. And if I do that, now it's returning the first bar, this blue one, 2 values, and this 2 values. Okay. The next thing is that same thing I have done here. Now we will add the label. So bar, this axis object also directly having a bar label to reduce the customization, that's complexity, that already they have provided a bar label. I'm iterating through again this C container, getting the values and saving into a label, these values. Okay. And each time during iteration, I'm adding to the axis. So axis dot bar labels, then the container, this is the container, and the label type will be center. The center, we would like to add the labels in the center. And what will be the label? The labels will be the labels that we are getting each time we are iterating through that with the list and saving in the list comprehension, and size would be 14. Next things are same, like removing the spines, adding the axis labels, legends. Okay, and if I run that, voila, it is there. Okay, I hope it is interesting so to see how we can customize anything in a bar plot. Okay, so we are accessing through the container, going through the for loop. Each container, again, we are using a for loop to access each bars, like this blue one first, then blue one second, then red one this first, red one second. Then we are adding a condition, if the height is greater than 0, only then it's return these things and add a percentage. I'm also converting into str here. I have not shown that. So because I would like to say a percentage string added into that actually. Okay. And if it is 0, then return into string, because I don't want a bar where it is shows 0%. So directly it will plot this. And we can save same way inside the images folder, stack bar plot.png. Now the pandas part. Whatever the customization we did to plot this actually using this thing in pandas, it is very easy. Just we'll take the data, that data contains this df1 or df. Okay, that has the data. Again, we will initiate a figure and axis object, plt.subplots, figure size is 12/6, and this df inside that with double, you can use lock also or ilock. I'm using this double quotation method to select this no and yes column. This 2 columns exist. If you don't provide, that is also okay, because it only contains these 2 columns only. Then this plot, then dot bar. This plot method also contain a bar method, and here you have to give just stack equal to true. Instead of dodge, it will plot a stack. Then you have to give the axis object, axis equal to axis, width of the bar, and edge color will be black. You enter, it will plot. That is very easy with pandas. If you have a pandas data frame and you would like to plot using pandas method, pandas plot method, that also uses in background the matplotlib, but it is very short code. And the customization part is same. I will not go through it. This part I've already discussed. This part also discussed. Level, legend, and again customization. Same. Okay. Next, what I will show, it is for not categorical data, but for a representing the mean. Let's say I would like to add mean value. I would like to compute the mean tip for each day by female and male, and would like to plot like this. I would like to using the bar plot, and I also would like to add a mean bar to see where the average is going, that beyond the mean actually. For the average is 3, but in Saturday it is above 3. So in at Saturday the restaurant is getting say the tips is more than average. Like for Sunday it is more than both female and male cases, it is more than average, and other days it is less than average. Likewise, you would like to plot. Sometimes you need that also, like a mean or standard deviation. You would like to plot, and that could be possible also using a bar plot. I will show both the methods. First, I will show the data frame using pandas method. Okay, and then I will show the C1 method. So let's read the tips data set. I'm using head, that's why it is showing first two observation. So next thing, how we'll calculate the mean. So I have already shown you these things that that day using group by method. So tips, then dot group by. Inside that, first I would like to separate the data based on day. Then each day I would like to separate the data in based on sex, and from each data set based on the sex, I would like to take the tip and calculate the mean. Okay, so first I will separate the data based on day. Then within the day, like for Sunday, I will separate out the data based on sex, like male data for Sunday, female data for Sunday. And for male data from Sunday, I will calculate that mean tip, and for female data of Sunday, I will calculate the mean tip. That is the group by functionality. Okay, so group by first is using sex, and second is using first is day, and within day based on sex, and from each data I would like to take the tip, and we have aggregation method dot aggregate, where I would like to calculate the mean. And what we'll do, I will do unstack so that the row becomes columns for the index, and then I will apply dot round. That will give me that each day wise for sex, here sex is in the column female and male, and the day is in our index row, Friday, Saturday. What is the mean value? I think the round should be 2 because it is rounded everything like this. So 2 decimal place, up to 2 decimal place. Okay. So this data I'm saving in DF, and matplotlib always take like this. So we will use this DF data for plotting our that plot. Okay. So how we will do that? In here, I will use the pandas method. So axis object, again, we are defining the subplots with figure size this, that will return figure and axis. So next df.plot, and it kind would be bar because I'm using pandas method, not matplotlib. Matplotlib would be cumbersome. That's why I'm directly showing this method. So kind equal to bar, axis equal to this axis, color would be blue and green. Okay, and edge color would be black. So here is the plot. So for each Friday, it is vertical. We can also change the tick parameters, rotation direction. I already showed that. So for each Friday, Saturday, Sunday, and Tuesday, that is the mean. Okay. So let's go for the customization plot. So axis.patches, it contains 8 patches. First it will be 0, 1. First will be blue cases, 0, 1, 2, 3. Then 4, 5, 6, 7 for the green. Okay. It will go like that because it contains in a container. First, it contains the container for blue ones, then for green ones. Okay, like that. So if I would like to print what is this patch contains, so I could use a range function. It is not important, just I will show you that I will iterate through every patches and it would show the rectangle, XY position, their width and height. So 2.78, it would be around 2.78. Then this bar would be around 2.8. 2.8, this blue one, this one should be around 3 point something, so 3.37, and this one should be again green 3, green 4, and that same method we will use that we have used. So we will axis through, we'll iterate through using a for loop. The axis.patches that contains all the 8 patches or bars, And then with axis.annotate, first we'll give the value. For each patch, we'll get the height using getHeight, and we will also provide the XY coordinate. So p.getx and our height would be p.getHeight, and adding some values in x so that it will put in exact position. So if you don't put this thing, I have already estimated. So it will move it little bit left and also cover the top line of the bar. And t.set, I'm setting the color black and size 12. Again, the spines are off. Again, I'm setting the axis level and tick parameters. The level size is 14 and rotation is 0, because here the rotation, if you see, it is 90 degree. This tick levels for the x-axis. I would like to be a 0, so I set the 0. Again, I'm giving the legend, changing the legend. Instead of male female, I'm getting female for F, male M. Location is center, figure size, same thing. Just enter and it will plot. Okay, female and male. Legend and all the values, and are also customized. This X levels are now in horizontal direction. And next thing is adding a line here for mean line. So how will add a mean line? So it has axis H line or axis V line. Two functionalities are there in axis object. Axis H line means axis horizontal line. Axis V line means axis vertical line. So to add a horizontal line, I would like to add a horizontal line. So axis dot AXH line, and Y, where I would like to put it, where the mean value of the whole data set. So tips dot tip, that is I'm taking the tip column from tip data set and calculating the mean, applying the mean function. So it will put a horizontal line wherever the average of this whole data set. Color equal to red, line style equal to dashed, alpha, that is means opacity. I will not need exact to reduce its opacity or alpha value to 0.3. Next, I would like to add a text, because if you see the earlier thing, so here is a text. I would like to add text mean tip with whatever the tip value, and it should be dynamic. If the data changes, then this value should also change. Okay, instead of giving as a text, I will directly give through the data. We have already know the dot formatter method, so I will show how to do that. So I've already shown that how to add the horizontal line. And next, from matplotlib.text, because I would like to add a text, import the text. There is a text method available that we will use to add the text over the line. Okay, so where would we will taking this text function, and inside that giving the x and y position. So x would be 0.3 around. If it is 0 to 1, this axis, like here x, and y should be wherever the mean is available, mean line is available. So y tip.mean, and from instead of adding over the line, I would like to give a little bit space over that. So 0.1 I'm adding on to that. So what will be the text? I'm using a f string. You can using a dot formatter. Okay, so f string, in the string, in this curly braces. So first it will print this mean tip, and inside this curly braces, I'm directly giving this tip, mean tip value. So using the round function externally, it will round up to 3 decimal place, and inside that I'm giving tips.tip.mean. That tips data set, from tips data set, take tip column and calculate the mean, and color should be red. And then axis dot add text method to add that text, whatever the text we are creating. So even if you add more rows to your observation or data set, the mean will be automatically adjusted, because we are giving is a f string, or you can use the we have already shown the dot format. Same way you can add this as a formatter. Next, the thing is we would like to customize the legend. I will show it later. Let's just run this. Now you can see that here it's put a line that is red in color and mean tip, and automatically calculated the mean using from the tips column, and with 3 decimal place it has imposed on that plot actually. Okay, so next thing I would like to customize little bit, because this hello, am I audible right now? The net disconnected somehow. Please post in the chat box so that I will continue. Anyone? Okay. Okay, then I will continue. So next thing, I would like to little bit customize this box, this legend, sex, female and male, and I would like to do using this function. So axis object having has a legend underscore attribute, and that contains the legend patch. And inside that legend is a bbox style. This looks complex, but it will come with practice, because even I can't remember those things, so I have to write down somewhere else as a note. So this kind of code, this will get you'll get this whole notebook and you can use that. And what I'm doing here, I'm taking the legend and the legend patch, this one, and setting the box style to round. The corner should be round. Pad, the padding of the from the text of the edges should be 0.5, and rounding size, what would be the corner will be rounded to 2. And again, legend patch, set face color. The face color would be white. And again, set bbox to anchor. I've already shown that. Where I would like to fix, the x position should be 0.5, y position should be 0.3. And if I print that, now it is rounded, you can see. And the edge, a pad of 0.2, I guess, padding is 0.5 is added also. Okay, this way it's been plotted. And now I will show the simplest method using Seaborn. That is a very easy way. So Seaborn also has a bar plot method. Also, you can use the cat plot method. That is also true, because I'm showing this to illustrate that another method is also available. So figure axis, again, we are instantiating the new figure. Subplots, figure size equal to 10, 5. And sns.barplot, that barplot function under Seaborn is available. So sns is the alias. We have already imported the Seaborn as a sns. So barplot. In x-axis, I'm giving tip. Y-axis. Okay, this need tips dataset. That doesn't need actually this way actually, because in matplotlib or pandas based method required the dataset in this way, and they in index wise, and column should be in sex, male, female, and male column. But Seaborn doesn't require that. Seaborn, you will directly use the data, load the tips data, and now you can directly plot. Okay, so tips data that contains sex, then it's a tips amount, okay, and day. So what we'll do in x-axis, I'm asking Seaborn take the date day and put the day in x-axis. In y-axis, put the tip and hue. That means the color fill based on the sex. So male and female, you'll plot the data in different bars separately. Take the data from tips directly. Give the axis equal to axis. This axis object, over that it will improve. An estimator. What would be the height of the bar? It should be np.min. So numpy, I'm using the numpy method, np.min. So CI confidence interval is none. I will show if you make it true, what will happen. Then what will be the order? So order of the X level should be first put the Friday. I'm asking Seaborn to do that. The first put the Friday, then Saturday, then Sunday, then Thursday. I like in this series, this way. Then palette. Also Seaborn supports different palettes, but here I'm manually giving it. Give a palette, the first one to blue and second bar to green. And it will plot that. Okay. So same way it is possible. And here estimator, if you use the np.std standard deviation, it will plot the standard deviation. If you plot the median, it will plot the median. So that way Seaborn is very customizable. And the error bar, I hope true will work. So there is the error bar you can locate, but it is very small. Some plots requires error bar where you can put the 95% confidence error bar. It is also can be possible, but here it is showing very small. So let me increase the resolution to DPI equal to 300. Now you can see that the error bar is very small, but sometimes it go very big. Position the legend in Seaborn. Okay. The Seaborn by default, wherever it will found the best location, it will put the legend. But same way, it is also possible to adjust, because we have the axis object, we can alter that also. So let me remove that. It will cover the whole screen. Here is the plot customization, same way that we have used for the matplotlib. That is pandas method. Okay. So again, through each patches, set the edge color of the each patch to black. Then annotate getting the height and put it in XY position, and set the color to black and size. Then remove the spines, add the labels, customize the legend, add a horizontal line, add the text, and also the legend customization, make it round. And if you add, and same way. I hope it answered the question. Position of the legend. Okay. You can adjust this position if you would like to change. Let's say I would like to change it to say x 0.2 and height should be 0.7. Like here, 0.2. This C-bond by default takes this whole axis range is 0 to 1. So it will take like this. So 0.2 is around here, x, and y is 0.7. This total axis is 0 to 1. So at center would be 0.7. Okay. That is customizable. And there is some formatting issue, I guess. I need to fix that, but right now it can be also added, the color of the this female and male, but I will do it later. So we will take break, I guess. What is the time? It is or should I proceed with the pie chart? Please write in the comment box, else I will show the pie chart. It is small, but it's very powerful. So anything can be customizable. You can use a matplotlib, you can use pandas plotting, you can use C-bond. Anything is customizable if you have the axis and figure out. Break. Everyone wants break right now for lunch. Otherwise, it will take 5 to 10 minutes to cover the pie chart. Break. Okay, then we will close it for break. In the next session, we'll start at 3 by Durgesh sir. And after that session, I will cover the C-bond, other plots types like pie chart. Let me show you the pie chart. Then box plot examples, then box and plot, histogram, violin plot, DSOM plot. That will be using all C-bond. So don't worry, it will take very few syntax and it will take very less time. Then join plot like this, and pair plot, combination plot of all variables, numeric variables. Okay, so we'll start at 3. Okay, and we will close now for lunch break.